name is Rivera, and I'll be representing Dairy Airlines today. Dairy Airlines is an airline which operates 5 days of the year to soak up demand which has not been met on very high demand for times of the year. For this portion of the year, we were able to secure 7 different airports. And we decided on running 17 different flights, and we will be doing so on 14 CRJ 702s. And the 7 airports which we will be operating out of are DAB, where we have 12 maximum departures, EAWR, where we have 13, MDW, where we will have 11, Denver, where we will have 13, MSY, where we'll have 18, DFW, where we'll have 15, and SJU, where we'll have 9. The 17 flights which we operate are all going to or from one of the 7 airports listed before, and each of our aircraft will be located at one of the airports previously mentioned. The aircraft were acquired through the company Rent-A-Plane, where they have a strict enforcement where each aircraft is not allowed to exceed 15 flight hours throughout the entire day. In the table in front of you, there is a summary of all of the flights which we expect to be operating on this day. As you can see, the information presented is a route from an airport of origin and the destination airport, the time it would take for the aircraft to make this journey, and the revenue and cost for each of these flights per person. In addition, we have listed the takeoff and landing fees for each respective airport, which will be crucial in determining the cost, as well as parameters about the aircraft, such as the average in-flight speed, the fuel economy, the price of fuel, the restriction imposed to us by Rent-A-Plane, and the rental price of the aircraft. It is also important to note that because of our extremely low cost, which can be seen in the previous slide, during the high demand time of the year, we actually are able to maintain a load factor of 100%, which makes things very nice for us as an airline. So in order to model the profit could be defined as the summation of revenues subtracted by the summation of expenses. For Dairy Airlines, the expenses come down to a mixture between the takeoff and landing fees, the fuel, and the price of renting each aircraft. The price of renting each aircraft, the fuel and the takeoff and landing fees have been collected and summated into the cost per seat, as you can see under the summation of expenses, and then the price of renting every aircraft has been summed, but as you can see, in front of you. In addition, the revenue of the aircraft was also determined, and that was given to us by the product of sums of the number of flights we could expect on making and the respective price, where the price came from the pricing team. Here we have an array which represents the departures of each aircraft. This is essentially modeling the restriction of departures that we have for each aircraft, where the order is Daytona Beach, Newark, Midway, and so forth, where each of the variables represent a different flight which we have in our network. In addition, we also had to model the flight hours as per the restriction from Rent-A-Plane, and in order to model this, the respective amount of minutes each flight would have taken is multiplied by the number of flights that we expect we will be making. So for example, if the first flight, if DA2 or 103 was 115 minutes and we will be making that trip 3 times, we can expect to be flying an aircraft 345 minutes, which is then related to the total number of flight hours we can have. And just for the ease and accuracy of the calculations, the hours have been converted into minutes, and yes, that's pretty much it. In addition, one of the less obvious constraints that we would have is a pretty simple one. You can't have more aircraft leaving an airport than aircraft have ever been to that airport. In order to model that, the number of aircraft, the locations where each aircraft has started their operation on the network has been modeled by the inbound flights subtracted by the outbound flights must be greater than or equal to the negative of the amount of flights that were there. For example, for the airport DAB, if there are three aircraft coming in and there are 6 flights coming out, the only logical explanation that such a thing can happen is that there are 3 or more aircraft at DAB prior to those inbound flights. By utilizing the same logic across all of the aircraft in our fleet and all the airports we have, we can avoid any issues coming in between, or any issues from aircraft that don't exist carrying people for some reason. With the constraints and the yield function modeled, it was possible to come up with a result which gave us the most profit. And as you can see, the result came to be that we have an array of flights coming in. One of the failed to be mentioned constraints of before was that the marketing team has said that each flight must depart once, and the reason being is for exposure for the next time when we will be operating again. Moving onward, as you can see here, we have 4 flights for the DA-101. We have 7 flights for DA-114, 3 flights for DA-127, and so on and so forth. And these flights are projected to yield $223,131.76 for profit for the company. That is taking into consideration fuel, airport landing and takeoff fees, in addition to the price associated with actually being able to utilize the aircraft. It is also worth mentioning that at the end of the entire operation, there will be 6 aircraft left over and stationed in Daytona Beach International, and 8 aircraft stationed in San Juan. This information would be extremely useful if this airline were to operate with the same aircraft the next day, but since it will not, this is relatively irrelevant information for the airline. But if this were to be taken further and applied to an airline which will be utilizing the same aircraft the next day, it would be possible for this information to be fed forward and utilized for calculating projected profits for the next day. And it may yield in changing what would happen in one day due to results which may be more beneficial the next day. Moving on, there are some improvements which could be made to this model, and one of them would be to model the demand as a dynamic entry as a function of price or as a function of timing, and include the time of day element. And what that would do it would allow for the price to also be optimized in order to maintain a load factor that is as high as it could be, instead of setting it to an arbitrarily low number in order to ensure a maximum load factor. And with that, I conclude my presentation. I hope you enjoyed it, and have a great holiday break.